All right, 4.3. Quadratic functions and their properties. Woo! Oh my gosh, we're talking about something other than linear? Yes. We enter our quadratic section, okay? 4.3, 4.4, and 4.5 are your quadratic sections. For quadratics, we're going to talk about their graphs, transformations, vertex, axis of symmetry, graphing the quadratic using this vertex axis, find the quadratic function with the vertex in one point, find the max or min. All of this should feel and sound relatively familiar. Yes. So what we spent 3 weeks on in Algebra 2, we're going to spend 2 days, if that. Okay, here we go. All right. So quadratic function, it's ax squared plus bx plus c. Agreed? Yes. All right. And c is always our y-intercept. This guy is your y-intercept. Okay. So here we go. The revenue R derived from selling X calculators at the price P per calculator is equal to the unit selling price P of the calculator times the number of X units. So here they gave us our graph to illustrate this. So we have R of P equals negative 150P squared plus 21,000P, right? Once we graph in the calculator and change our window, we can see that it creates a quadratic, a negative quadratic, right? So here, I'm going to graph negative 150, but instead of P, I'm using X squared plus 21,000 X. I'm going to change my window. So my X min is 0. My X max is 140. I'm going to count by 20s. I have 0 for Y. I go up to 800,000. I'm going to count by 100,000s. And I'm going to hit graph. And bam, there's my beauty. Okay. So that's as simple as graphing and identifying, and then I can create a table, find whatever. So to create a given table, if I know the price per calculator, then I know how many calculators are being sold. And so this is a reverse. They're telling you 60. So if the price is 60, then they're going to sell 12,000 calculators. If the price is 65, this is using reverse table. So instead of your dependent being on auto, your dependent is on ask. So then you would go to your table and you're looking for 60. Is it going to let me do it? Hold on. I think I got to turn everything on. Auto. I think that's how it works. I haven't did this by calculator in a while. I know that in X it lets me. That's not what I need. I need to put in the Y. Maybe I'm wrong. Who knows? Okay. It's all you need to be able to do. Understanding that some of your variables that you're given are going to have to be changed when you put them in the graph. So in this example, it's a projectile motion example of using Newton's second law of motion. Force equals mass times acceleration. And so you can see how this is coming together, and it's creating another example of quadratic functions. Doesn't want you to do anything, but it just wants you to be able to see, recognize, and kind of be able to identify when something is creating a quadratic function. All right, so quadratic transformations. Just like all other transformations, quadratic transformations are affected the same, except your A and your B kind of sometimes work in opposites and favors of each other. Main thing here is your A. If your A is positive, no matter what, if your A is positive, it's going to be above the x-axis, right? And so above the x-axis, bam. If your A is greater than 1, then it's going to cause it to stretch. So notice how I call it the quadratic is working out. If it works out more, it's going to get skinty. If it cuts its time in half from working out, it's going to get a little wider. Okay, same thing here. If your A is less than 0, your A is going to be reflected, and it's going to be a negative parabola, negative quadratic. And these are the two types of things that happen. If your A is greater than 1, it's going to stretch. It's going to get skinny. It worked out 3 times a week instead of half of the week, half of its time. Okay, so here, when you have just an ax squared, so a simple quadratic, all you're doing is thinking about how it's being affected. Okay, so again, A increases. So if A is increasing, getting larger, then it's going to be a stretch. It's getting taller, right? If your A is less than 1, but greater than 0, so the absolute value of it is smaller than 1, that's going to make it look short and fat, shorter, stocky situation there. Okay, and then again, if it's positive, then it's going to be open up. If it's negative, it's going to be open down. Okay, so I'm going fairly quickly. We call this concaved up, right? If it's positive, then it's concaved up. And it creates what's called a minimum value, okay? So it has an absolute minimum when it is concaved up. Sounds about right? And when we're concave down, we have an absolute max. Cool? Okay. So them side by side, these create your vertex, your vertices, and your vertices are either going to be a maximum or a minimum. A minimum is your lowest point and it's concave up. Or maximum is your highest point and it's going to be concave down. Okay, so this would be our positive quadratic. And this guy is our negative quadratic. Notice how I call them smiling in the sad face. Huh? Yeah, I know. I try to be. All right, so you should be able to find the vertex without a graph and with a graph. So with a graph, by hand, we did completing the square before. So you can do completing the square and factoring out and getting a loan and all that good stuff. And then you can do it that way, or you can use your vertex formula. So your vertex formula is negative b divided by 2a, comma, the output of that, plugged in. So I know my a is 3, my b is -6, right? So I plug this in. So I get -6 divided by 2 times 3. And that equals 6 divided by 6, which is 1. So what this means to find the y value, I'm going to substitute 1 into the function. And that gives me 3 times 1 squared minus 6 times 1 plus 5. So coming together, we end up with 1. 3 minus 6 is -3. -3 plus 5 is 2. So my vertex is at 1, 2. So this is using the vertex formula. Okay, now we're going to look at not using the vertex formula, and that's using completing the square. So it's completing the square. Can I erase the vertex formula? Completing the square, that's where we're trying to get our variables by themselves. So the first thing you're going to do is you look at the first two terms. So I'm going to look at 3x squared and 6x. I'm going to factor out their common coefficient factor, which in this case is 3. So I factor out 3. And when I factor out 3, I'm then going to complete the square by dividing 2 and then squaring it. So we have 2 divided by 2 squared, which equals 1. Agreed? So I'm going to add 1 to the inside. So adding 1 to the inside actually means that I added 3 because it will be 3 times 1. In order for this equation not to be changed, if I add 3, in order to keep it balanced, I'm going to have to subtract 3, which is why this says minus 3. And now because of difference of squares, I can rewrite this as 3 times x minus 1 squared plus 2. And what this is left in is in vertex form. Vertex form is your a times x minus h squared plus your k. Uh-oh. And h and k are your vertex. Personally, I like the vertex formula. However, I'm supposed to remind you of completing the square. Did we still not get 1 and 2 in the end? H would be 1. Remember, our x is a liar. Our x is a liar. So h would be 1 and k would be 2. Do you have to do completing the square to find the vertex? No, you can do the vertex formula. Okay. So when it comes all together, we can then graph it, transform it. The reason why you need your h and your k, because your vertex tells you where you're shifting left and right and up and down. And that's your transformation. Okay, so vertex form, fully explained. And again, when it all comes down to it, this is your full vertex formula. If you don't want to have to actually plug back in, you can do the math, 4ac minus b squared over 4a, or just substitute back in and just multiply. But that's your other option if you prefer to do vertex formula versus completing the square. Personally, I wouldn't be mad at you. Okay, I prefer to remember this and just tell myself to plug in versus having to remember all of this. Again, personal preference. Totally up to you. All right, identifying the vertex and axis of symmetry. So here it is, simplify. And your axis of symmetry is whatever the x value of your vertex is, right? Whatever the x value of your vertex is, that is your axis of symmetry. So here we have negative 2x squared plus 8x minus 3, and it's asking, is it concave up or down? So we're going, in order to answer that, we got to look at our a. And what is our a? A is negative. And because a is negative, it's a sad parabola. So it would be concave down. Do you feel comfortable doing that? Awesome. Here's your full explanation. If you wanted to go through it, you could figure it out, but you don't have to. Did it ask us for the vertex? Oh, it didn't want the vertex. Oopsie. So then we're going to find our vertex. So we know it's concave down, and then to find our vertex, you have your A and your B, right? So we have negative b divided by 2a equals negative 8 divided by 2 times negative 2, which is 2. Okay, so that's part 1. That gives us our h. Part 2 is to find our k. So we do f of 2, which equals negative 2 times 2 squared plus 8 times 2 minus 3, which gives us negative 2 times 4 is 8. 8 times 2 is 16. And now we do some math. What's 8 minus 16? Negative 8 minus 3. Negative 11. So this is my k. So therefore my vertex is at 2, negative 11. And we know that our function is concave down. Okay? Because our vertex is at 2, negative 11, that means our axis of symmetry is at x equals 2. We got our vertex, our axis of symmetry, and we answered the question. Is this something you could feel like you could do on your own? Crazy how we spent a whole day doing this, right? In previous class, the whole day was devoted to this. And we spent 6 minutes reviewing. Okay? All right, questions about that? None? Cool. Here's the full explanation all written out for you. You identify your A, your B, and your C. You substitute those values in. Once you find your H, you substitute in to find your K. Did I do math wrong? I did. It was a plus? Fudge sickles. It was a plus. Okay, good thing I write it out. Equals 5. So our vertex is at 2, 5. You never saw anything else. And our axis of symmetry is x equals 2. Okay, and we know that A is negative, so it's concave down. Cool. You plug the value you get in for the first part. Yep. It's like a puzzle piece. It's all connected. All right, so the graph of function using its vertex and axis of symmetry. Okay, so the main thing here is your x-intercepts. Your x-intercepts, you're based on your discriminant, which is b squared minus 4ac. It determines whether you're going to have 1, 2, or no x-intercepts, right? So you're either going to have 2, 1, or 0, okay? If your discriminant, which is b squared minus 4ac, is positive, then you're going to end up with 2 places. If your b squared minus 4ac equals 0, then you're going to end up with only 1. So it's at the vertex. 1, and it's your vertex. And if your discriminant is b squared minus 4ac is negative, then the graph has no x-intercepts, no real solution, okay? So that means they'll never cross the x-axis. Sounds familiar? So picture-wise, it looks like this. We either have view touching twice, view touching once, or never touching you. Capiche? All right. Anyone's like, I've never seen or heard of any of this. All right. And then there's it drawn out better for you. Pretty sketches. All right. So how to graph quadratics by hand using its properties. So in order to graph, you need your x-intercepts, your y-intercept, and your axis of your vertex. So the first thing you want to do is to decide if it's concave up or concave down. So for this situation, it would be concave down because our A is what? Negative. Okay. After that, we want to find the vertex. And we already did. Bam. There's our vertex. And our axis of symmetry. Then we want to find our intercepts. So to find our intercepts, the y is always your c value, right? So y is the easiest to find because it's your c value. And so we end up with that. Now what's harder is your discriminant to find your x value. So when you're looking for your x-intercepts, I'm going to check to see what type I produce and if I'm going to have 1, 2, or none. Plug them in to this handy dandy, what's this guy called? Quadratic Formula. And that tells you my x-intercepts. And I graph it all together and bam. I now am going to graph everything that I have and draw a sketchy sketch. And that's how you draw. Okay? You will have to sketch out a quadratic on your test. Freehand in the non-calculator part. So let me know if you need help.